Okay, here we want to look at the Gauss-Jordan method for finding the inverse of a matrix. Now we've already looked at a method to find the inverse where we use the 1 over the determinant, and then we switch the entries on the main diagonal and negate the other entries. But we want to look at this one. This is used more often when we have 3x3s, 4x4s, and just larger matrices in general. But I do just want to show you this method for brevity with a 2x2. So what we do, we want to find the inverse of 1, 2, 3, 4. So we list our matrix and our identity matrix. Our goal is to turn our matrix A into the identity matrix. These same row operations will simultaneously change the identity matrix into the inverse. So let's look at what we do. The first thing we want to do, we want to say -3 row 1 plus row 2 to give us a new row 2. So that's 1, 2. This will be 0 and -2. And now these same operations, -3 times 1 is -3. -3 times 0 plus 1 is 1. Okay, now we still need to make A into the identity matrix. So the next thing I would do, I would add row 2 plus row 1. Okay, that's going to give us row 2 plus row 1 to give us a new row 1. So now we have 1, 0, 0, -2, -2, 1, -3 and 1. So we're getting closer and closer to finding our inverse. The next step that we will do, I'm coming down to this negative, to the next line. To make this -2 into a 1, I would multiply -1/2 times row 2 to give us a new row 2. That gives us 1, 0, and 0, 1. And now we do the same thing with the other row. Now this is going to give us -1/2 times -3, positive 3/2, and -1/2 times 1 is equal to -1/2. So now our the inverse of 1, 2, 3, 4 is this: -2, 1, 3/2, and -1/2. Because we've turned the matrix A into the inverse, into the identity matrix, and the same operations have turned the identity matrix into the inverse. So now I'll show you here. This is A. This is the identity matrix. And through all of our operations, our row operations, we turn this into the inverse. Okay, now just to do a quick check, let's look at it. Once again, if A is equal to 1, 2, 3, 4, let's look at the other method. A inverse, if we can remember, that's going to be 1 over 4 minus 6. I'm just going to show every step. Okay, which is equal to negative 1/2 times 4, negative 2, negative 3, and negative 1, which simplifies all the way down to negative 2, 1, 3/2, and 1/2 through scalar multiplication. So as you can see, this inverse that we've got from the first method that we learned is the same here.